2 observation points lie on level ground from a vertical tower. The farther point is 16 meters beyond the nearer point. The 2 tangent ratios describe sight lines to the same tower top, and we need the tower's height.
This is a student-produced response question, so there are no answer choices to test. We must build the geometry carefully and enter the numerical height ourselves.
The source figure shows 2 right triangles sharing the same vertical leg. The nearer observation point makes the steeper sight line, and the farther point makes the shallower one.
Let x be the horizontal distance from the tower to the nearer point. Let h be the tower's vertical height. Those 2 quantities form the legs of the smaller right triangle.
From the nearer point, tangent means opposite over adjacent. The opposite leg is h, the adjacent leg is x, and the given tangent is 3/4.
Multiply both sides by x. The same statement becomes h equals 3/4 of the nearer horizontal distance.
Now comes the key distance decision. The farther point is 16 meters farther from the tower than the nearer point. Its distance is not 16, it is x plus 16.
Look again at the level ground segment. The labeled 16 meters is only the gap between the 2 observation points. The full farther distance includes the nearer distance x as well.
From the farther point, the opposite leg is still the same height h, but the adjacent leg is now x plus 16. The given tangent is 5/12.
Multiply both sides by x plus 16. The second expression for the very same tower height is 5/12 times x plus 16.
Both right triangles reach the same tower top, so their height expressions must be equal. This eliminates h and leaves one equation in x.
To clear the denominators, multiply every term by 12. 12 times 3/4 is 9, and 12 times 5/12 is 5.
Distribute the 5 on the right. 5 times x plus 5 times 16 gives 5x plus 80.
Subtract 5x from both sides. 4x equals 80, so the nearer observation point is 20 meters from the tower.
20 is an intermediate distance, not the requested answer. The question asks for height, so we substitute x equals 20 into either height equation.
Using the nearer triangle is simplest. 3/4 of 20 is 15.
Before accepting 15, verify both tangent ratios. In the nearer triangle, opposite over adjacent is 15 over 20, which reduces to 3/4.
The farther point must be 20 plus 16, or 36 meters, from the tower. That uses the full ground distance shown by the 2 adjacent parts.
Now check the farther triangle. 15 over 36 reduces by 3 to 5 over 12, exactly matching the given tangent.
The figure now fits every value: a 20-meter nearer distance, a 16-meter gap, a 36-meter farther distance, and one 15-meter vertical height.
There is also a height-first route. From the nearer equation, x equals 4/3 h. From the farther equation, x plus 16 equals 12/5 h.
Subtract the nearer distance from the farther distance. The x terms cancel, and the known separation of 16 equals 12/5 h minus 4/3 h.
With denominator 15, 12/5 is 36/15, and 4/3 is 20/15. Their difference is 16/15.
Divide by 16 and multiply by 15. The alternative method gives h equals 15 again, so the result does not depend on which variable we eliminate first.
The common trap is treating 16 as the entire farther distance. Doing that would ignore the segment from the tower to the nearer point and break the geometry in the source figure.
We also never need to calculate either angle. The tangent values are already the ratios of opposite height to adjacent ground distance, which is exactly the information the model needs.
The canonical answer is 15 meters. It satisfies both tangent ratios and preserves the 16-meter separation between the observation points.
The reusable strategy is to label the nearer distance, add the known separation for the farther distance, write tangent twice with one shared height, and then solve and verify both triangles.
Nearer distance 20, farther distance 36, and height 15. Both checks match the original ratios, so the tower's height is 15 meters.